Okay, is anyone absent today? No, I think we're all here. Which is good, because the recordings haven't really, they keep having errors on them. Okay, now we're on that one? Alright. Chapter 5, which don't only forget to give you your homework stuff for Chapter 5. That's Chapter 3. I might have to write down Chapter 5, the first one at least. Okay, at the end we'll do that. Alright, today we're going to learn how to find increasing and decreasing intervals. There's many steps you need to go through, and your answer has to be written a certain way. So you can't put it in your own language. You have to write it showing calculus, the proof that we use in calculus on why it is like this. So, find steps to determine whether a function is increasing or decreasing. The first step is to identify the domain. Identify the domain. The second step is to find dy dx. Look at dy dx. So, okay, what else? Do we have good more what prime? It could be y prime or it could be f prime, depending on how it's written. Okay. The next step is to find the critical point. Critical points are when dy dx equals 0. If the derivative equals 0, what's happening on the original y function? Right, okay, it has the slope because what's happening on the function? What's happening at that point? So should be m. We got it. Min or max, it's peaking. Because if you come around on the minimum or maximum, you hit a slope of 0 before you come back down, right? So the derivative is 0 at that point. So dy dx is 0, and or when dy dx is undefined, would be one of the critical points when something's happening there. Okay, then we're going to use a number line to find. Step G, use a number line to find where dy dx is positive and negative. We just use plus and minuses. You cannot use the number line for your answer or for justification. It's a nice process to help us along the way, but it cannot be your justification for your answer. It's not allowed. 0 points for you if you say because of my number line. Or they call this also a sign chart. Okay? You cannot use that for your final answer. It's just a nice step along the way. And then we write your answer. Okay? Long steps, we'll go through them on a variety of different problems. Okay, so our first problem, we have a cubic function. You agree with cubic? Has this polynomial as part of x cubed. So we're going to go through all the steps on it. A, first of all, we need to identify the domain. I like to put d sub x, because I remember the domain is the extent of the x's horizontally. What's the cubic function's domain? Maybe the infinity. The way we're going to say all reals, right? That breaks the cubic function. Okay? Part B. Now we're going to find dy dx, or in this case, what should we call it? F prime x, because it's in f of x notation. Okay, we should just be able to spell this off. Christian, can you give me the f prime function, please? I'll make this a little bigger too, so we can see it all. What's that f prime? What? Over, I think I'm to over. 3. Yeah, that just multiplies. Okay, keep going. Good. Okay, so this can simplify to just a 1 x squared, right? So 3 over 3. Okay, now we're going to find the critical point. This is now what type of function? Quadratic. Does quadratic have critical points? Where the critical point you're looking for is when it is equal to 0 or it's undefined. Is a quadratic ever undefined? No. But are there points where the slope could be 0? dy dx equals, well, dy dx equals 0. So the slope of the original f function would be 0. Yeah, there could be points where this equals 0. So how do we find that? Exactly. Okay, so for part C, we need to look at 2 things. When f of x equals 0, and we already identified this one, but f of x equals undefined. And we said never, right, for undefined? Because quadratics are never undefined. So we're going to take our f prime functions that equal to 0, and then move it back in secondary math to how do we solve quadratic that equals 0? Factor. 2 numbers that multiply to negative 15 and add to negative 2. Do we agree with this? X minus 5, x plus 3? Negative 5 and 3 is negative 15. Negative 5 plus 3 is negative 2. Okay, well, how? Not equal to 0. So this is called the 0 property. We take x minus 5 and equal it to 0. So one of our critical points is that x equaling 5. And the other critical point is that x equaling negative 3. Are we okay with that? So our derivative function of prime has 2 x-intercepts, at 5 and negative 3. What do these represent on the original f function? Maximums and mins. So we have changing from increasing and decreasing. Right now it's not clear whether the maximums or mins, but we know there's either a maximum min at x equals 5 and x equals negative 3. Is that clear? Okay. After we found critical points, and we also check the undefined, now it's never. Next part B. So number line, other critical points. So this number line is for f prime of x, so read it. And we have negative 3 and 5. This is also called a sign chart. And we're just going to go through and put pluses and minuses in these little windows. So we can see whether we actually have maximums or mins and the intervals at which f is increasing or decreasing. So what you do is you come back to f prime, which is right here, and you put in values. What's to the left of negative 3? Negative 4. So you quickly plug in negative 4 into f prime without a calculator, so most of these will be done without calculators. Of operations, we have 16 plus 8 minus 15, so what do we get? 24 minus 15, so essentially what we care about is it's positive. Yeah? So no plus. If you really care about the number, what we care about is the sign. What's the easiest number to plug in between negative and 5? 0. I would go to 0. 0 squared minus 2 times 0, cancel, cancel. So what's the sign? Negative. And then something greater than 5? Sure, we do 6, but we have squares, so let's choose a number that we can easily square. Okay, so we have 36 minus 12 minus 15, 24 minus 15, what's our sign? Positive. So notice what happens at the critical points. Is it changing positive, negative, positive? So the derivative is positive, negative, positive. What does that mean that f of x is doing? When the derivative is positive, what is f doing? Increasing. When the derivative is negative, what is f doing? Decreasing. And what should I put right here? What happens again? Increase. So make sure you label this sign chart we did for f prime, the derivative. And then above it, I said increase, decrease, increase. And I labeled it f of x. Okay? And then part E is just an answer. Now we're going to take that information and write our answer. So the questions are, what intervals are we increasing or decreasing and justify? Okay, so f, the original function f, is increasing on this section. What do we call this section? Negative infinity to negative. What you were talking about is inequality notation, which also works. So x would have to be less than negative 3, but not equal to. That would also work. But generally, I do interval notation. From negative infinity to negative 3. What's happening at the max? Is it increasing or decreasing when it's at the max? It's not stop, it's still moving, but at the max, is it increasing or decreasing? Neither. So that's a trick question. Neither. So we're not going to close bracket, we're going to open. Okay? And there's another section, right? From 5 to 5 to positive infinity. Now you have to justify it. You cannot just leave your sign chart to justify it. You must say why. Because f prime of x is greater than 0. So f is increasing on these intervals because, refer back to f prime. Don't just say because my sign chart shows it. No. What are we looking for? F prime has to be greater than 0. Okay? Also, let's do our decreasing. F is decreasing on, you can tell me the interval of time when F is decreasing.
Bracket.
Not bracket. Parentheses. T5. Because, why? F prime of x is, we know it's decreasing because f prime of x is less than 0. This would be a quality answer. Okay? Okay, let's try another one. The more and more I go through, the quicker you'll pick up on it, and it'll go fast eventually. You know there's lots of steps. Man, you're talkative today. Where's number 2? Yeah, mine's not there. Oh, it's there. Okay. It's there. Alright. So, first step now, you have to identify as actually a continuous function in a domain everywhere. What type of function is number 2? It's an exponential, right? Would it have a horizontal rotation because the negative is inside the function? So it's a horizontal rotation, but they're exponential functions. Continuous everywhere, we have a domain from the infinity to positive infinity. Yeah. Each of x is negative a to positive infinity. Okay, part B. Find dy dx. So in this case, f prime of x. From here, we're going to have to apply to take the derivative of e to the negative 3x. Well, you can, but it's really a chain rule. If you think about it as a chain rule, I think it's easier. Because what's the derivative of e to the x? E to the x is e to the x. It's itself. So we have a negative 3 to the x. Chain rule is f prime, which is e to the x, stuck with the original, times by the derivative of the exponent, -3. So do a table on an e function. That's super easy. You just write the original function and then times by the derivative of the exponent. That's the table on the e. Okay. What's the next step? Find critical points. So we're looking for critical points when f prime of x equals 0 and, so we have two different scenarios, undefined. Okay? So let's talk really quick about this graph. I already mentioned the vertical rotation or homologous rotation. A normal y equals e to the x function is just this, right? And cross is, what's e to the 0? 1. Okay? This time, we almost have a y equals e to the positive 3x. But still, what's e to the 0? E to the 3 times 0, which is just e to the 0. Still 1. What does the negative do? Ooh, that's an x. So, this way, right? It was a horizontal rotation. So, is there any place where this graph touches the x-axis? No, because we don't have any vertical shift. This, if we have anything after the e to the x, we have a vertical shift minimized, but this is never. Okay. What about, are there any places where we're undefined? No. Okay, so, no critical points found. Let's talk about a sign chart. We have a sign chart for f prime of x. So we don't have any critical points to plug in. So from -3 to positive 3 is this graph. Positive or negative? Remember, we look at positives and negatives first. Is the derivatives graph. Remember, this is our derivative. So this is our everything's positive, everything's above. Well, actually, no, this is the original. This is the original, right? So the derivative, though, has a -3. So the -3, all it does is flip it. So it's all negative because we have a vertical flip right there, -3. So it's all negative. So that means that the parent function f of x, if f prime is negative everywhere, then f of x is not negative. Decreasing everywhere, which we already drew that graph. That was true. It was decreasing everywhere. Okay, so our answer is C, D, E. Our answer, f of x, is increasing where? Nowhere, right? Or you could say f of x never increases. We cancel out f of x decreases on what's the interval? Negative positive infinity, because always justify it. How do we know this?
Because the amplified is
F prime of less than 0 everywhere, right? Really, we can just stop even here. The F prime, or you can say always. F prime of x is less than 0 always. Okay, let's try another one. this? A rational is a fraction. What should be 1 over x? I think this is a rational times a linear. That'll be actually have a name for us. Let's think about the domain of play. What's the domain? D of x. Except for negative 2, so the only one. Positive 2. We get that from factoring the denominator. Two numbers that multiply in negative form and add to 0 with x plus 2x minus 2. So I have 2 moments where I'm undefined. Either of these are movable, discontinuities. No, so they're not whole, running on the graph. They're not removable. Which type? Vertical asymptotes. So I'm going to do these asymptotes like that. The domain, okay? We have vertical asymptotes at x equaling plus or minus 2. Can you tell me the domain of this function leaving out positive and negative 2 because it's not on the domain? Bracket or a parenthesis? Okay? Good. Union. Good. So we have 2 holes there. Well, it would class those there and there. So there's 3 sections of domain. Okay? Part B. What do we do on B?
Find the
Yeah, find the derivative. Okay? So, k prime of x in this case, what rules can we apply? Quotient rule, what's it saying? Really high minus high low over low, or low squared. Okay. The next one, can you do the numerator? Really high minus high low? Really high minus, okay? High. Good. Over, and we have the denominator squared, x squared minus 4 all squared. Okay? That was kind of messy. Let's see if we can, and we need like critical points, so let's see if we can clean this up a little bit. We'll find my one of j thing, and this becomes a negative 2x squared, right? Can that clean up anymore? X squared. So x squared minus 2x squared is a negative x squared minus 4. Ooh! Could I just cancel those out?
No.
Because it was negative. If I just, or if I back out the negative, it would become x squared plus squared. They don't actually match. So you can't just cancel them out. Okay, but now we have our k prime function all cleaned up, so we can find critical points. We must test 2 areas. So for C, when k prime of x equals 0, and when k prime of x is undefined. Okay? 1G, when would k prime of x be undefined? So we're undefined when we have division by 0 issue. So what part of this fraction gives us a division by 0 problem? The numerator and the denominator. Denominator, that's what we divide by, right? Divided by the denominator. So the denominator can't be 0. So I'm going to break it up, x squared minus 4 times x squared minus 4 cannot equal 0. And then we already covered this one earlier, right? X to minus 4 gave us what factors? X plus 2 and x minus 2. And then we can say this all squared because there were two of them. So we're going to find a plus and minus 2. So those are critical points. We okay with that? Brendan? Alright, now when k prime of x equals 0, we don't have to do all this. You can set it all equal to 0, but really, what part do we actually need to set equal to 0? The numerator, because if I take this denominator times on both sides, it just disappears. So really, I just need to take the numerator set equal to 0. So in undefined, which is the denominator, equal to 0. We want a fraction for k prime equal to 0, we took the numerator equal to 0. So what are our two critical points here? Did you get it, Matthew? We're solving for x. So f1 over negative x squared equals 4. And what do you have to do to solve for x? Not yet. Divide by negative 1. So negative 4 equals x squared. How do we get rid of squared? Square root. So they're our critical points. Plus and minus 2i, which are those actually x-intercepts? No. So there are none here. Never does f k prime of x equal 0. When you solve quadratics and you have imaginary solutions, that means the graph never touches the x-axis. So our critical point is always on the undefined portion, plus or minus 2. So now we do our number line, our sign chart, ACD. The sign chart is for k or k prime. K prime. Make sure you label it so you always know it's not k, because some people get confused by that. It's k prime. Make sure you put these numbers in order for the negative first, the positive second. So if you label it, you should know which function to plug into. You're going to plug into the k prime function. Okay, what's a number less than negative 2 that we can plug in? Negative 3. Okay, and k prime is negative x squared minus 4 all over negative 3 squared minus 4 all squared. Takes a little bit of work, but we need to know the sign. So work it out. Don't care about the answer, we care about the sign of the answer. And that are based around initial interval of increasing and decreasing. And like 6 free response questions in total, which is a good chunk of the test score. So if you can do this one, that would, there's almost always one like this. Okay, what did you get for your sign? It should be negative. Because we have a negative 9 minus 4, which is negative. And what's happening in the denominator when you square it? Do you really have to work it out? No, you're squaring everything, so it has to be positive. So a negative divided by a positive is a negative. Now we need something between negative 2 and positive 2. We just want to put in 0. So negative 0 squared minus 4 times something all squared. The denominator is automatically positive because we're squaring it. The numerator is negative, so this interval is also negative. And then one more, how about positive 3? Negative 3 squared minus 4 over something squared. As long as it's already positive, the numerator is not positive. It's negative. Negative 9 minus 4. So we get negative. So the intervals of increasing and decreasing is this increasing number. No, because k prime is never positive. So for our answers, k, we can do that. K of x is decreasing. Where? Don't say everywhere, it's not acceptable. Negative infinity to positive infinity. So on the symbol. It doesn't say on the set of all real numbers. I think that's wrong though. Because k prime of x, we change the x. Less than 0 is put up always. I think less than 0 everywhere, but I always put it. Okay. Let's do a trig one, which is on your worksheet. So, under number 4, split that space in half. I'm going to give you a trig one really quick. It's not on your worksheet. Split that space in half, and then number 4, and do number 5, give you a trig one. Y equals cosine of x minus pi over 3 on the interval from 0, which is less than x, which is lesser than equal to 5 pi over 3. It's a little different in two ways. We don't have all rules that we're looking at. We have a restricted interval from 0 to 5 pi over 3, and it's a trig function. And the cosine function continues everywhere. So we have the domain normally from the infinity to positive infinity. That's our domain this time. What's the domain this time? 0 to 5 pi thirds, what goes around each of them? 1, 0, 0, because there's no underline. We have to get it here, because that one has an equal to. Okay? Part B. Y prime. Y prime. Kennedy, which rule do we apply to take the derivative of the right-hand side? Chain rule, exactly. Can you tell me what we get for the chain rule? We can look at it all the time. The outcome is cosine of x. The answer is there's not a good thing with pivot. X minus pi base. Okay, now prime of x. What's the derivative of cosine? Negative sign. Derivative of codes are negative, or change signs. G of x, G prime is 1. Alright, that's right. X all times by 1, which we all have to write. Are we okay there? Chain rule? Okay, part C, critical points. When y prime of x equals 0, and when y prime of x is undefined. Now let's think of the cosine function. Is it ever undefined? No, never. Well, even the sine function, I guess, the y prime is actually a negative sine function. Now, where is y prime, which is x-axis? First of all, a negative sine function, y prime equals negative sine, goes like this, right? 5 pi thirds, and that's before 2 pi. Okay, what happens with this minus pi over 3? What does this do to the graph? It's a what? Horizontal shift, which direction? The right. Remember, opposite, same. Horizontal shift, right. Pi thirds. So all of these original critical points, which was at 0, pi, and 2 pi, all get shifted to the right by pi thirds. So r y prime, which equals negative sine of x minus pi thirds, doesn't start at 0. Where does that loop start? Pi thirds. So it's here at pi thirds. So 0 plus pi thirds is pi thirds. And then where's the first other 0? It used to be at pi, but now it's at pi plus pi thirds, which I heard over there. It's 4 pi thirds. This used to be 2 pi, but now it's 2 pi plus the shift moving to the right pi thirds. So this is like 6 over 3, so 7 pi thirds. And then we're looking at the interval from there to there. But are we looking all the way to 7 pi thirds? No, somewhere in here it's 5 pi thirds. Here's 4 pi thirds, 7 pi thirds, 5 pi thirds, and somewhere like right there. So how many critical points do we have? 2.
2.
Pi thirds and 4 pi thirds. Okay, I think we're going to stop there so we can answer questions real quick on the last section from chapter 4. And the third test will probably take most of the class next time. So I'll finish with the 5-1 next time, and I'll give you the homework for 5-1 next time, and the new let's see next time. So your only real homework this time is to finish up 4-1 and study, memorize your derivative formulas, because there will be no hits. 4-2, thank you. Okay, so what questions do you have really quick on 4-2? Then on page there. 4-2. Can I see this? Christine, you have a question? No. Yeah? That's a study guide for you. I put the answer, I think I put them on Canvas. So go there, Canvas, so you don't see. Clear modules. We did that last time, implicit differentiation. That's all the answers right. But then, oh look, solutions. Last time I did all the solutions on Canvas for last Friday has the solutions to all kinds of things to it. I'm not going to touch that from you though. But you really should go home. We saw today that some of them are really involved. So here's the solutions to that packet I gave you. You should be able to do all those in that packet. Okay, so 4-2, questions? Anna? Well, which one do you want first? 21. Okay, so we're going to go about 21. Right. Okay, this one says find the lines that are tangent, which means both and normal. So we need equations. Okay, the derivative only gives you the slope. You have the point given to you that in order to find the line tangent, you need a slope. So I must derive each side, right? Do the x on that. Do the x for that. Okay, I'm just going to go back. We don't have time. This derivative is 12x. Ooh, product rule. Okay. First, you can pop out the 3 if you want. Let me take the first as 3x. first to last, derivative of y is dy dx, right? Plus last is y, d first, 3. Plus 4y, what do you have to put after y if we take the derivative? Dy dx. Plus 17 dy dx. Derivative of 6 is 0. Equals 0. Okay, so I'm going to find the right terms. Dy dx, dy dx's, dy dx's. And we're going to, let's see, what?
One third here was 3x dy dx, 4y dy dx. So
they're all in the common dy dx's. So I'm going to factor out the dy dx and put in my 3x plus 4y plus 17. You can write them separately, but then we combine them, they'll have dy dx's. And then I'm going to move this guy to the other side, because it doesn't have a dy dx. I'm also going to move this guy to the other side, because it doesn't have a dy dx. And then solve for dy dx. Divide 3x plus 4y plus 17, but divide in everything. 3x plus 4y plus 17. So that's what dy dx equals. Do we know x and do we know y so that we can find the slope? X was, and then really you can plug it in at the beginning, I just always forget it, so I do it at the end. Minus 3 times 0. 3 times -1 plus 4 times 0 plus 17. So that cancels. 12 over -3 plus 17, which is 12 over 14, which is 6, 7. This is the slope of the tangent line at -1, 0. What's the slope of the normal? -7, 6. Does that get you far enough that you can now write your equation using this? Okay. What was the other one? 27. Do this over here. Guys, let's get through 27 really quick. At least jumpstart on it. You can put it on dy dx and the second derivative. This is a circle centered at the origin with radius 1. You have your side ones out, we already have this done. So derivative 2x plus 2y dy dx, because we equals 0. So solve for dy dx. Gotta move this over, gotta move this over. 2y dy dx equals -2x. Divided by 2y, divided by 2y, so dy dx equals -x over y. I don't need to give you a point, so I think that's it. And then you take the derivative of that doing quotient rule. Okay, can you finish that? Right. Now your homework. Study group quizzes. If you don't understand how to be perfect, I'm doing half the points. So perfect. And unless they do dy dx equal, but you don't put dy dx equal, it's automatically wrong. Yeah. Yeah, because that's an expression, so it's equal. But if it's an equation, you have to keep it as an equation. Y, differentiation, so we haven't seen y yet, so it would be this, once we back it up, so it would be y times by the derivative of that, which is dy dx. You can look at it short.